Hey guys, welcome back to another video. And today we're going to be doing even more chemistry stuff. Sorry about the weird angle and the weird lighting. I'm actually going to be doing an experiment with baking soda, right? That's what we're going to be doing today. So, right now, what's going on is I had to switch out the camera for my printer cam because the old camera was not working as well anymore. Um, and yeah, okay. So, now that that's out the way, I will show y'all what we are achieving today. I believe this is upside down, so you actually just want to keep it like this. Beautiful. All right. I don't know how. Oh yeah, this thing, the camera thing is short as well. So let me see if this works. This might actually work. Hey, that's not bad. All right, let me make my camera smaller. There we go. Okay. Jeez, I look a bit different. I think might just hair. I don't know. Okay. So first things first. What are we doing? Okay, that's not open anymore. What are we doing? Today we're going to be we're going to be doing a chemical reaction where we're taking baking soda, which is sodium bicarbonate. Hello. Yep, sodium bicarbonate, sodium, hydrogen, carbon, and oxygen. And we're going to be converting that into sodium carbonate. The reaction is super simple. All you need to do is heat it up and it'll decompose. Right? So first things first, we're not just going to do everything, right? We have to set something. We're going to do, right? So if I was going to do this experiment, I'm going to open up a Google Doc sheet for this. Please open. Oh, brother. That's amazing. I'm going to take off my glasses for a second. There we go. Alright, you want to go down to Google Docs, and then we're going to go over and open up a new document. Sorry, my recording setup, because I have 3 monitors. One in front of me, one over here, and one over here. Technically, there's one on the floor, because it was over there by the lab setup I just showed you. However, I took it out because we're doing stuff over there. So my recording setup is on this monitor over here. Anyways, so here's what we're going to be. Here's what we're going to be doing, right? We're going to be goodness gracious. We're going to be converting sodium bicarbonate, which is, let me move this over. This is very important as well, this part. It's 2 molecules of NaHC. I hear the dog barking. O3, right? It's very important because whenever we're going to do our percent composition of this to figure out how much sodium carbonate we're going to get, the fact that it's 2 molecules is going to be important. Okay, so let's carry on. Right, we're going to be converting that into sodium carbonate, which is, yeah, okay. So this is just going to be Na2CO3. The difference is it's not 2 molecules, and there's no hydrogen, so yeah, there's no hydrogen. Oh, and there's an extra sodium ion. There's an extra sodium. There we go. Yep. Oh, and there's 2 carbons apparently. No, there isn't. There's 2 sodiums. I'm confusing myself. It's because it's okay. You know what? You know what we probably could do, and I'm not getting off track here. I'll probably have this video chaptered off, so it's easier to look at. But I want to see if we can. Is it symbols special equation? Yeah. Oh, brother. Oh, here it is. Okay, new equation. Okay. You know what? I think we're good. I think we're well good. I don't think we need that. Alright. Y'all know what I mean, though. Actually, you know what I probably could do? Let me see if this works. Hello. Oh, it's because I didn't... Oh, well, it doesn't work. Well, so y'all get it, right? It's 2 sodiums, 1 carbon, and 3 oxygen from this molecule, um, which is itself, the molecule is a single sodium ion, or no, not the molecule itself, because I just basically said the same thing. The individual structure. So it's basically the same thing. 2 sodium, 2 hydrogen, and 2 carbon, 6 oxygen. Now here's why this is important, right? Because this decomposition, whenever it's added to heat, somewhere around 200 C, I think, yeah, it decomposes into sodium carbonate. But you're forgetting something. There's 6 oxygen. There's 6 oxygen, so this only leaves 3. We need 3 more, and we also need that hydrogen. There's 2 hydrogens somewhere, right? So what it actually forms as well is water, and then it also forms carbon dioxide. And as you can see from balancing chemical equations, you know, if we're turning this into all these 3 products, as you can see, 3 oxygen, so that's 6 oxygen from the molecule. You got 1 carbon here and another carbon here. That's correct, because in this molecule there's 2 carbon, and in this molecule there's also 2 hydrogen. 2 hydrogen right here. And then we come over here, we got 2 um, yes, 2 sodium, which is also in the molecule, 2 sodium. Now, you can't, we're not just going to do the thing, right? I want to make sure I'm recording. Okay. Here's what we are going to do, right? Let's say I take 100 grams of the sodium bicarbonate, and I did the reaction, right? My question is, how many grams of sodium carbonate, hello, sodium carbonate, water, and what is that? Carbon dioxide would I get? That's a very interesting question. Now, here's what you can't do. You can't just say from 100 grams of sodium bicarbonate, if I were to do that reaction, I would get 33 grams of sodium carbonate, 33 grams of water, and 30 grams of carbon dioxide. No. Very important piece here is that that is not correct. Um, because of percent compositions, because of how the masses of atoms are, you wouldn't just divide it by 3, right? Especially not because it's just not how it divides up. You can't divide. There's not 3 sodium ions. No, sorry, 3 sodium atoms. There's not 3 carbons. There's not 3 oxygens, right? And it wouldn't even work in the first place. So here's how you would do it. First, we need to find out the entire mass of sodium bicarbonate. How do we do that? Well, here's how we're going to do that. We're going to take, if it would do it. Okay. Well, thanks for embarrassing me. So, we're going to pull up our period table, right? I'm going to keep this on screen. I don't think there's a good way for me to show multiple of my screens now without squishing them. So we're not going to do that. I got a little bit of hair stuck to me. There we go. Okay. So here's how we're going to do this first, right? We're going to take this, because in total we have 100 grams of sodium bicarbonate, which is this stuff. So how we're going to do this, right? This is a molecule, remember. So it's, for right now, the simplest thing to do is just calculate a single structure of this molecule. I don't know what the single parts are called, but it's like a single structure of the molecule, and then just multiply that by 2. Because we won't have to deal with multiplying in between. So we're not gonna, I'll keep that right there. For now, we'll just focus on this part. So, firstly, I believe it would be called the grams per mole of sodium bicarbonate, right? I do things a little bit differently because it's, I don't know, it's just easier sometimes just to do it the way like this instead of having to put everything over one. But essentially the reason why that's important is because, especially when you start getting into molecules and moles and different, when you start getting into molecules, 2, 3, 4, 5 of the same molecule, of a molecule, you're going to need those conversions. However, what's simpler here is just to factor it into the equation as we're doing it. So grams of mole per sodium carbonate, right? So of sodium carbonate, 1/2. No. Okay, simple thing to do. We're going to come over here. Sodium Na is 22.990. Let's see. Let me just put these down. C and then O. H is going to be 1. Yeah, it's 1.78. 0.78. C, which is 12.01. And O, which is 15.9999. 3 million nines. Okay, so simplest way to do this, we're going to pull up our calculator. Drink some water. Delicious, right? So, easiest way to do this, treat this as a single molecule, and then, where did my calculator go? Is it on the hotbar still? No. Is it? Wait, where is it? Oh, okay, yeah, no. Okay, yeah, we'll just do this. All right. So we know that this single part of the structured molecule has a single sodium, and then it has, right, so single sodium, and then it has hydrogen, has a single hydrogen, so 1.0078, and then it has a single carbon, so 12.01. And then it has 3 oxygen. Now, how are you going to do this? Because this calculator doesn't support the calculation I'm about to do. We go to Google and do it. Right? Calculator. We're going to put in 15.999 times 3, which is 47.997. And can I copy and paste? I can. Okay. 84. Now, keep in mind, that's only for a single structure of this molecule. So we're just going to double that. 168.0116. That's going to be that is going to be the total grams of moles for this molecule, sodium bicarbonate, right? Now, what do we do from here? Well, I'm going to go over to sodium carbonate and figure out the grams per moles for that one, right? So, gram mole of sodium carbonate. Thank you, carbonate. And we haven't even gotten to the 100 gram stuff yet. Just wait. Alright? Alright, so we already know everything here because we know that the values are right here and nothing changes atom-wise. So All right, sodium. So we got a single sodium. Sorry, excuse me. We have, actually, no, we don't. That's tripping me up. We have 2 sodiums times 2. Okay. We have a single carbon, which is, yeah, 12. Like there. Is my, hold on, let me see if I can move this so I'm not under the camera screen. Uh, and then we have 3 oxygen. Again, this doesn't support what I'm about to do. We already know it's this amount, though. Where'd my document, and where's my calculator? Okay. So, just putting it in. Oh, let me make sure that's right. Let me make sure that's correct. 2 sodium, 1 carbon, and 3 oxygen. Perfect. All right, so we have a grand amount of 105.988. So I'm going to go ahead and put that in here, right? So, perfect. Now, I'm going to do the other ones before we start calculating. So, the grams per mole of water. Okay, grams per mole of water. We know some things already. 1.0078 times 2. So that's how much water, and then add 15.999. Boom. Okay, so it should be 18, should be this guy. Sig figs. Brother. Oh man, this is gonna be upsetting, but we'll be fine. Alright. I'll do it when it actually, like, kind of, not really, like, when it matters, but, like, right now, we're trying to get, like, pure numbers of grams and whatnot. And I mean, what's kind of important is that it kind of already did it for us. If we really needed to, then we would honestly just round up this and round up this to match, this guy. Because then it'll be more accurate. So I'm probably actually just going to do that. It'll be simpler. This will help us there. So now it's matching this. Alright, carbon dioxide, CO2. Pretty simple, just bring up the calculator again. C 12.011. And then, what? Okay. Actually, first, because I have to go into that separate tab, we're just going to calculate for oxygen on this first. Boom. And then you can add in the carbon. There we go. All right. 44 point, please. Just, there we go. Okay. Boom. That's accurate to a T. All right. All right, we're good. So, now what you can do is you can take, this is going to be the percent composition part. So, sodium carbonate, so now we can take the amount of sodium carbonate. Alright, so here's the cool part, right? What we can do is we can say the different parts, like if we were to take all 3 of these, like, okay, let me see if I can try and do it first before I try to explain it. So basically what I'm going to do here is I'm going to put in 105.988, and I'm going to divide that by 168.012. So that's going to be, that's about 63%. I'm not going to convert it because I don't need it converted. However, what we're going to do with this number, this is when we start getting into like the amount of grams per, like, that we're going to get out of the thing. So now what we're going to do, Oh, this is a decomposition reaction, by the way. I don't know if I already mentioned that, but that's kind of what it is. All right. So here's how I'm gonna do this. All we have to do is just multiply this number by 100. Interesting. Yeah. Right. Hold on. Hold on. Let me just check my quick calculations real quick. Okay. If we're gonna check the calculations, we'll do it after. I'm not going to be rounding on my numbers, the ones I'm calculating. I'm going to be rounding here, though. Not really rounding, but just like removing. So we should get about, how many decimal? We had 3. So 0.084 grams. Let me put something in the front here. Boop. Of sodium carbonate. Grams of water. How many grams of water we're going to get? Well, oh, yeah, I don't want to delete these yet because I'm going to calculate these at the end, so we can also delete all this calculator. Okay, you know what? If Google doesn't want to help me, then Google's not going to do anything, right? Simplest way to do this. Boom. And then just put that over there. We don't need it, right? So now we're going to do the grams of water. That is incredibly simple as well. Just take our, the amount of grams per mole, 1 point, this, and this. Yep. And then we're going to divide that by 168.012. Boom. And then we're going to multiply that by 100. So we should be getting about, let's see, what is it rounding onto my sheet? 722, no rounding. Grams. All right. We got that. Now let's go ahead and put that into the other calculator here. Press enter and then press the plus sign again just to do it. Right. So next up is the grams of carbon dioxide. All right. From the reaction. Pretty simple. Just put in 44.009 and then divide that by 168.012 and then multiply that by 100. And okay, just before I start, like, to explain why we're multiplying it by 100, that's because the number I just calculated out before I multiplied it by 100 is the percent itself. We're not multiplying it by 100 to get the percent. We're multiplying it by 100 because 100 is the amount of grams that I'm going to be using, I hope. And if I'm not, then I'm going to have to come back here and do a whole bunch of other calculations. Alright. I'll only put this in here. 100 grams. Bingo! Right. So, approximately 26.194. That's rounded up. GTA's grams. Rounded. Alright. Oh, just, this was, I was actually adding each of these back into each other, and it got 100. So that means it's fairly accurate. So that means, so in a decomposition reaction of sodium bicarbonate into of a sodium bicarbonate molecule of 100, so in a decomposition reaction of 100 grams of sodium bicarbonate, you should get 63 grams of sodium carbonate around 11 to 11 grams of water and 26 grams of carbon dioxide. Now, does that mean you're actually going to get that? No. That's just theoretical values, right? Um, that's just what's going to happen in theory, right? Next step is the actual reaction itself. I actually have the I'm going to go ahead and delete my calculators. I actually have the pre-steps to making that chemical reaction, the procedure. I'm going to need baking soda, some sort of hot plate, which I have right here. I use this to melt lead. Oh yeah, I cleaned it out, so it shouldn't have any more lead in it, which would be pretty scary. Heat safe container, yeah. Scale, I have a scale. Spoon, oven mitts. Oh yeah, PPE, safety wise, right? I cannot for the life of me find my safety glasses, so I'm just gonna be using these and hoping they work. I do have heat gloves for this thing because that's what they came with, and they do actually work fairly well. I've touched that thing multiple times and nothing has happened. Heat doesn't transfer through them to my fingers at all. Would there be anything else I would need? Maybe like a mask. Oh, well-ventilated room. I'm gonna have the window open with the fan blowing out of it, so it should work. And I'm also considering whether or not I should just do this, but by doing that, I don't guarantee how much of the heat is going into here, because the most amount of heat is going to be in the bottom of the container. So in truth, I don't know, right? Let me see if I can put you all on a good vantage point. I'm going to remove this foot real quick. There we go. Alright, y'all are going to go right here. Hey, that doesn't look too bad. You can see all the stuff I'm doing. Alright. Before I do any of this, I'm going to look up any of the hazards and whatnot, and then I'm going to go grab 100 grams of sodium bicarbonate. And I'm going to make sure I tell y'all if I do grab 100 grams, because if I don't, I'll tell y'all, and I'll tell y'all the new values for everything. Oh, procedures, right. We're going to be weighing out 100 grams of baking soda. I'm going to be making this from baking soda. 100 grams of baking soda, and then we're going to be putting it in that thing, and then, oh, actually, I'm going to turn that on, let it sit for a bit, and then I'll be putting it in there. Once I think it's heated up enough, I don't know if it is, and then I'm just going to put it in there once it's done, once it's ready, and then we're going to have to let it sit for about an hour. Turn off, an hour? Never really let that thing sit for an hour before, but, okay, turn off, okay. And then we're going to let it dry after an hour, and then we're going to weigh it again. And in theory, it should be about close to 63 grams of sodium carbonate. Alright, so I will be back. Sorry about that. I forgot to mention one key thing, just in case anything goes wrong, that I do have on me, and I've always had this. Fire extinguisher. Don't try this at home. Parents are going to get mad, because it's going to stink. We're back. Here is the 100 grams of baking soda. Baking soda. Okay? This is just baking soda, nothing dangerous. Unless you ingest it all. That's dangerous, don't do that. Great. That's that. I'm going to go ahead and plug in this thing, and we're going to turn it on. I might pause the video so that, you don't have to just sit here and watch it turn on. I don't know what this is. I just unplugged it. Plug in the little guy. Now, oh, right. Ventilating the room. As for doing that, let's open the window. Hup. No! Sorry. That it just fell on all my stuff. Alright. Let's go ahead and get this thing running. Up! Alright. We have opened up everything. This is on. I'm turning it down. Let me see what the max is real quick. Okay. Turning it down to do 50. Alright. Oh, 220 actually. So turn that down just a little bit more. You might hear the background noise of the fan blowing, but that's just the background noise. I should be able to catch anything that's happening because my camera. So what we're going to do here is now that that's done, I'm just going to expand my camera. So now y'all can see the full picture, right? Ignore my messy, oh my goodness, guys. Ignore my messy bedroom. Ignore it. It's not even focused. I put the table in focus for a reason. You know what? Stop being so nosy, guys. Quit being so nosy. You noisy people. There. Alright, now it's just focused on the lab stuff. Oh, right. I forgot to put on my safety equipment. Alright. I put on my glasses, and now we're going to put on gloves. Boom. And the only reason why I really put on gloves is, for one, if anything is left in here, if any lead is left in here, it won't splatter on my hands. And also, if, what was I going to say? Oh, because this thing's going to get hot. Like, can't really feel the heat, but I know it's heating up. So, yeah. I might or pause the video until I know it's heated up, and then I'm going to put the stuff in. Most likely, I don't know if I want to put the lid on or not. The only reason why this is here... Oh, right, we were going to do that thing. That's fine. I've also dumped out any of the particles that could be in here. So, we should be good on that. This is just for fires, just in case the fire starts, I can put this on. I've done that multiple times, that's why it's kind of... You can't really see it, but there's a bunch of there's like a dark streak in there. Yep, there we go. It's singed from putting out fires. So, and I want this thing ventilated anyways because there's a lot of heat. Sorry, there's a lot of, there might be lead vapor still coming off of here from a whole bunch of other times. Like, this is pure lead. It's a very big chunk of lead. This is pure lead right here. Right, that's supposed to be a pawn. Over here, it's not pure lead, but it still has some lead in it. Don't know where it is, but it's literally just like a manufactured like nut. Because usually I do a lot of sand casting. So I take sand and, I take sand. I make a mold out of the sand. I put metal in that mold. I take it out, and it makes this really cool thing. So, yeah, I do a lot of that. I don't smell anything, which is good. I would rather not smell anything right now, because if I did, then... Honestly, too, I'll take something from over here. I'll use it to block up the door, because I don't want any of these vapors kind of just escaping my room right now. Because if I'm being honest, my parents have already gotten mad at me for something like that, where I don't melt metal in my room anymore, because last time I did, my parents got mad at me because I don't know if it was metal or if it was plastic. It was one of the two. But yeah, this thing is taking a while to heat up. And it's not that very controlled either. Sorry. There's nothing we can do but sit and wait for this thing to really... Oh, one way I can kind of tell if this thing is actually heating or not is by putting a little bit of plastic just kind of sitting there. This plastic is specifically PETG, so it would melt at this temperature, or it would start to, yeah, so this thing is nowhere near heated up. I can kind of see, like, stuff coming off of it. No, it's nowhere near where it's supposed to be. So, we'll just have to wait a little bit more. Can you smell that lead in the air? No, yeah, I mean, with the amount of type of soldering that I've done and whatever this thing is, there's a lot of metal in my lungs. Can you see my foot? Okay, oh, never mind. Whatever. Kind of excited. This is my first reaction. First chemistry thing I've done on my own. Right. I'm either just going to let it run on the video or I'm going to pause it, one of the two. Because I don't know how long this thing's going to take to heat up to the right temperature. And there is no real way to tell if it's heated up or not. So maybe I'll just run it over like that, and maybe it'll just heat or figure it out. Or actually, you know what I can do? Doop. Yeah, no, barely 100 degrees Fahrenheit. Barely even anything. Like, okay, the reason why, because these, my finger's not in frame. Amazing. These hot plate, I know this one, right? That hot plate, the one that, okay, do you see in the corner of the video, I'm going to be referring to video, bottom right, that triangle thing, that's essentially this, but it's like a square, it's still square, but you're sitting on it. That, I know that one can heat up to 100 C at most. This reaction requires about 200 C degrees Celsius. So we're just kind of waiting at this point for it to heat up. And I don't have any real good way of telling whether or not it's hot. Huh. I didn't know that was on my thing. There's a person outside my window. Like, they literally had the complete opportunity for the whole entire sidewalk to be able to see me. I'm gonna bend around the window. I don't see them anymore. That was scary. Yeah, no, there was a person outside. Yeah. Oh, look, you're starting to see little. I don't know what 100. I know to the skin it's hot, right? 100 C's hot to the skin. So this thing just might take a while to heat up. Yeah. The scale I used isn't exactly as exact as it exactly should be exactly. So this is about 100 grams because it goes down to the single digits at most. So you're getting about 100, and then give or take that point. Anything below the decimal is just going to be estimated. I'd estimate about 0.9 because it's barely, right? Barely below 101. So we're going to expect to see maybe just a little bit more. No, probably still a little bit less due to the amount of variables I have in my system. Honestly, you know, be cool. You know what? Just like a thing, right? We do. But I'm gonna turn on this printer. You can see like the screen turned on and stuff. and we're going to see how much the bed plate can heat up to. So we're going to go ahead and do that right now. Actually, it's whatever. It'll just, I mean, it'll not really tell you, but it'll just like show you how much. So bed plate's going to be the green one. 100. Okay, so the max this thing can go to is 100 degrees Celsius on the bed plate. Although I don't know the max. I probably should have left the machine on and just checked. It's probably gonna be 250. The max the nozzle can get to. Um, that's getting pretty warm. That's getting like barely anything really. It's like skin temperature. Again, barely anything. It's interesting how slowly it heats up. I mean, of course, it is a $30 setup, so you're not gonna get much for it anyways, which sucks. But that's just what it is. Right, we're gonna check the nozzle temperature. 300! Wow. Okay, so this thing can go up to 300 degrees Celsius on the nozzle. That's very high. I wonder what filament, because the most I run, I think, is the PETG at like 250 degrees Celsius, right? It's probably gonna be something carbon fiber related, or something infused with metal, because that's what usually takes up the most amount of heat. Are we even... I don't know. It's barely heating up. Again, this thing is not grand. And of course, I can't just heat it up all the way because it wouldn't really work at that point. So, again, don't have... Is there a bus? I think... Y'all hear that, right? The squeaking, the... Yeah, this thing is not heating up, like, in the slightest. Jeez. Yeah, this thing's terrible. Goodness gracious. Okay. Do I have any other better heat sources? Nope. I mean, the oven downstairs, of course, but I wouldn't get to sit here and watch it, really. So I'd just say, just bring it up, right? Because this thing is not gonna be even that hot to begin with. And I don't know why it's not heating up anymore. Yeah, because that should be like 10 times hotter to the touch. Oh! Goodness me! The outside is very hot. Okay, hold on. We're turning it down, we're turning it down. I see what's going on here. Okay, so here's what we'll do. We'll put this on top. Make sure it's not touching the wires, which it isn't. I think this should be enough. This should be a good amount to hold it. Hold this much baking soda. Please don't make a mess. Oh! Ah, man. Well, I don't know how much we just lost, but I don't even think that matters, because it just matters that there's baking soda over this thing now. So let's just kind of even it out so it's not just a big clump. Okay. I'll put that on there so it doesn't make too much or more of a mess. Alright. I honestly, the gases should be able to escape. So we should be fine. Oh, y'all saw that in clear daylight too, right there. Man. Um, nah, I don't know. I don't. Okay, this is terrible. If this doesn't work, I'm going to just use an oven. Guys, there's a white van outside of my house. It says delivery driver, but it's literally just in an orange box on the side of the van. I don't trust it. Alright. Looks like that's going. Hopefully. I'm about 10 seconds away from just going downstairs and putting this in the oven for about an hour. Which I think is probably the best decision to do. Because my room is also very humid. I see what's happening, yeah. You're face to face. Is this even heated up? Oh, wait, was it burning? What was it burning earlier? Ouch. Yeah, that's heated. Oh, wait. I wonder if y'all are picking up that static. Because I might want to just put it in there. It's not hot at all. I might just go ahead and put it in there. But first, we're going to transport this. I don't have traction control on. There we go. Traction control has been turned on. Alright, easiest way to do this. Open it up and just put it in there. Like so. Alright. Now, we can take this guy, put our gloves back on, and don't touch. Don't let the plastic touch, because it's going to melt the plastic. Dang it. Alright, careful. Alright, baking soda is in. That should serve to keep it heated. Great! Alright, I will come back to y'all in about an hour. So I will see y'all in a bit.